In this video, we're going to cover techniques for finding integrals of the form the integral of sine to the nth power of x times the cosine to the nth power of x with respect to x, or integrals with powers of secant of x multiplied by powers of tangent of x with respect to x, where either m or n is a positive integer. We're going to attempt to organize our integrals into combinations that will allow us to use the power rule. So for example, if I have the integral of sine cubed of x times cosine of x dx, you may be tempted to try and use something like integration by parts from the previous section, but that really wouldn't get you what you need in this particular instance. So if I were to consider my u to be sine of x, the u prime that I would need would be the derivative of that, which would be cosine of x. So that would make my du cosine of x dx, and you can see that we have that right here. So this is now the integral of u cubed du, which we know to be u to the fourth power divided by 4 because it's u to the n plus 1 divided by n plus 1, all plus c. And then I'm going to plug my u back in, so that will be sine of x to the fourth power divided by 4 plus c, which is a perfectly valid answer, but just for style purposes, we usually will write that as 1/4 times sine to the fourth power of x plus c as our final answer. Now the guidelines for evaluating these integrals involving powers of sine and cosine are shown here. If you have, for the first case, an odd sign, this power here is odd and positive, so something of the form 2k plus 1, then what you want to do is convert some of those to cosine, but we save the odd one for our du. And then we're going to use the Pythagorean identity to convert that to 1 minus cosine squared of x. And then we would distribute and evaluate the integrals using the technique we showed a moment ago. When the power of cosine is odd and positive, we save one cosine factor and convert the remaining factors to sines, and then we expand and integrate. Now, if the powers of both sine and cosine are even and non-negative, we might have to make repeated use of these power-reducing identities from trigonometry to convert the integrand to odd powers of the cosine, and then you can go from there. So let's look at an example. I have the integral of sine cubed of x times cosine to the fourth power of x dx, and I notice that my sine is raised to an odd power. So because we have sine raised to an odd power, we're going to save a sine of x for our du. So I'm going to rewrite this as the integral of sine squared of x cosine to the fourth of x, and then in parentheses I'm going to put sine of x that I'm going to reserve to be part of my du. So that's the special one. We're not going to mess with it. Now I'm going to take this sine squared of x and I'm going to convert it to cosine of x, and I know that sine squared of x plus cosine squared of x is equal to 1 from the Pythagorean identity, so that means that sine squared of x can be written as 1 minus cosine squared of x. So that's what I'm going to use here. So I'm going to have in parentheses 1 minus cosine squared of x, and that's going to be what was before sine squared of x, times cosine to the fourth of x, times that special sine of x that we are holding out to save for our du. Next, I'm going to distribute the cosines, so I will have 1 times cosine to the fourth power, which is cosine to the fourth power of x, and negative cosine squared of x times cosine to the fourth of x, which is minus cosine to the sixth of x, and that's all times that sine of x that I'm reserving. And then now I'm going to distribute everything again, so I'll have cosine to the fourth power of x times sine of x dx minus the integral of cosine to the sixth of x times sine of x dx. So you can see all that I've done is just basically distribute here. So next I'm going to choose u to be cosine of x, which means u prime is negative sine of x. So du will be negative sine of x dx. I almost have that. I just need a negative on each of these sine of x's. And if I place a negative here, that means I need to multiply by a negative on the outside of each integral, which will turn the first one negative and the second one positive. So this one is now the negative integral of u to the fourth du plus the integral of u to the sixth du. When I evaluate that, I'm going to raise the power by 1 and divide by whatever the new power is. So I'll get negative u to the fifth power over 5 plus u to the seventh power over 7 plus c. And then finally, the last step is to plug the cosine back in. So I'll have negative 1/5 cosine to the fifth power of x plus 1/7 cosine to the seventh power of x, all plus c. And that's going to be my final answer for this problem. So you can see the entire problem worked in front of you. Okay, here's another one where we have an odd positive sign. So again, I'm going to reserve one of my signs to be the du. So I'm going to write sine to the fourth of x times cosine to the fourth of x. And then I'm going to have that reserved sine of x that we're just going to kind of emphasize. We're not touching that one. It's protected, all with respect to x. So now I need to deal with this sine to the fourth of x, and I need to turn it into something in terms of cosine. So coming off to the side in your scratch paper, sine to the fourth power of x is equivalent to sine squared of x squared, because when you raise a power to a power, you multiply them. So I can replace what's in the parentheses with 1 minus cosine squared of x, just like I did in the last problem. But now I'm going to be squaring it. So when I FOIL that out, I get 1 minus 2 cosine squared of x plus cosine squared of x squared, or cosine to the fourth of x. So I'm going to come rewrite my entire integral. And where I had the sine to the fourth of x, I'm going to put this new expanded cosine expression. And then I'm going to have the original cosine to the fourth of x that was there, and my reserved sine of x. And now I'm going to go ahead and distribute. I'm just going to do all of the distributing in one step for this one. So for the first term, I'm going to have 1 times cosine to the fourth of x times sine of x dx. So that becomes cosine to the fourth of x. And then we've got our special sine of x dx. I'm going to have minus, let's put the 2 on the outside, times the integral of cosine squared times cosine to the fourth, which gives me cosine to the sixth of x, all times sine of x dx. And then lastly, so we've distributed this one and this one, lastly we're going to have plus the integral of cosine to the 8th power of x, because 4 plus 4 is 8, and then sine of x dx. Now, for all three of these problems, we're going to let u be cosine of x, which means u prime is negative sine of x, and du is negative sine of x dx. So again, I'm going to put the negative in there that I need, which means I need to multiply by a negative on the outside, which is just going to change signs all the way across the board. And this gives me negative integral of u to the fourth du plus 2 integral of u to the sixth du minus the integral of u to the 8th du. So that gives me negative 1/5 u to the fifth plus 2 over 7 times u to the 7th power minus 1 over 9 times u to the 9th power, all plus c. And then filling that cosine back in, I get negative 1/5 times cosine to the 5th of x plus 2 over 7 times cosine to the 7th of x minus 1 over 9 times cosine to the 9th power of x, all plus c. And that is my final answer.